In this video, I just wanted to go through how we can solve this kind of a question. So we're doing a geometric, so we know that it's a geometric progression or geometric sequence. We've been given two of the terms, so T3 and T6. We're not told the first term. We're told T3 is 20 and T6 is 160, and we want to find A and R. Sometimes you'll then go on to want to find other things from that, but I just wanted to focus on this part of the question. So we're using our general form of T of n is equal to A times R to the power of n minus 1. So we're going to use that T3 first, and we're going to write that 20 is equal to A times R. Now if we've got 3 there, n minus 1 is going to be 2. Then I'm going to use the next one and say I've got my 160 is equal to A times R to the 5, because it's T6, 6 take 1 is 5. I now have two pieces of information there, and I've got two unknowns. So I now want to solve for the A and the R. So one option is to rearrange those to get the A on its own. So that's an option. So I could write 20 on R squared is going to equal A. And then over here, I can write that 160 divided by R to the power of 5 is equal to A. I now have two relationships for A, or two equations that I can put together for A. So I can then say that 20 on R squared is equal to 160 on R to the power of 5. I now want to get all my R's together. So because we've got a bigger number on the bottom of the fraction, we don't want it on the bottom of a fraction, so that's the one we're going to move first. So I'm going to multiply both sides by R to the power of 5. That will get rid of this one on the bottom, so I'm just going to have 160. Over here, I've got 20 over R squared. I'm multiplying it by R to the power of 5, so I'll end up with 20R to the power of 3. If I wanted to show why that worked, I could have written that as, I'll just do it over the side here, 20R to the 5 over R squared, and you can see that that will cancel out the two of them on the bottom and leave us with the 3 on the top. So we get to this point. Now we want to get the R on its own. So we have our R cubed is equal to 80, because we've divided by, we've divided, R cubed is equal to 8. Sorry, we've divided by 20, not 2. So now we have R cubed equals 8. Now you might look at that and you might say, oh, well, I know that 2 cubed equals 8. But you might not know that. So if you weren't sure, this is why I wanted to show you this one. To get the R on its own, the opposite of doing to the power of 3 is doing to the power of 1 over 3. So we're doing to the cube root instead of to the cubed, R cubed, or and if you were thinking about that in terms of things you already have done, if you've got something squared, the opposite of that is doing the square root. If we have higher powers, we can keep going with that same process there. Now, when we do 8 to the power of 1/3 to the 1 over 3, we're going to get 2, which we said over here, you might have already recognized that as 2 to the power of 3 gives you 8. Now we've got R equals 2, we can sub that back in to get our A value, because we know that A, and we could have used either of them, A is equal to 20 on R squared. So 20 over 2 squared is 20 over 4, which equals 5. We could then check that in the other one if we wanted to, but now we have our A and our R, and we can go on to solve other questions with that. So hopefully that helps with solving these types of questions. Just remembering, if you're trying to undo an operation, so if you had, say, R to the power of 6 was equal to, I'm just picking a number here now. I might go with the same 2 here. I don't know, I'll put 64. Then I would do R is equal to 64 to the power of 1 over 6. And I'll get my calculator. I may get a decimal. So we'll go 64 to the power of 1 over 6 gives us 2. And in this case, I did work that one out right, so that was good. 2. So we can use that fractional indice to undo or work backwards when we have a power that we're trying to work out. Hopefully that is helpful and helps you tackle those types of questions.